welcome to another video. Hope you're ready to flex those brain muscles. In this video, we're going to be evaluating some trig functions and finding some exact values at different angles. So I'm going to go ahead and do this without having the unit circle in front of me. So we're going to use reference angles, coterminal angles, our knowledge of the quadrants and all this stuff. In fact, all I usually memorize are these three angles for sine and cosine. This is basically the first quadrant of the unit circle. You don't need to memorize the whole unit circle. If you know these and you know how the quadrants work and how to find reference angles, you can find the values of pretty much any trig function at any angle. So let's go and get started. Sine of 7 pi over 6. So I can immediately tell this isn't in the first quadrant. So the first thing I'm going to do is find a reference angle. So what I do is I usually draw a little cross here. It's like an x and y axis, but it's just a rough sketch. I know that since this is greater than pi, it's going to be right here in the third quadrant. And the reference angle, again, I draw from the angle, from the terminal side of the angle to the x-axis. So that's this angle in here. Since this is pi, that can be written as 6 pi over 6. So basically, I'm going pi over 6 radians past pi, if you want to think of it that way. So my reference angle is actually pi over 6. We know the sine of pi over 6 is 1/2. So this equals 1/2. The only thing I have to check now is if it's positive or negative. That's how reference angles work. It gives you the value, but you still may have to change the sign, positive or negative, depending on what quadrant it's in. So since we're in the third quadrant in this case, we know that sine is negative in the third quadrant because sine is y over r, and all my y's in the third and fourth quadrant are negative, so sine will be negative. So I just throw a negative in front of here, and we are done. Okay, now cosine of 5 pi over 3. Same idea. I know that it's not in the first quadrant. It's not one of my angles I have on here that I know. So I'm going to go ahead and draw just a little y and x axis. And again, if you're given or looking at your unit circle, you could just look and immediately tell what this is. But if you're not given it and you don't want to just memorize the whole thing, you can use this idea of reference angles. So I'm starting here. My angle's opening up. Let's see. This is pi, so that's 3 pi over 3. And this is actually going to end up being in the fourth quadrant. So when I'm finding my reference angle, I draw from the terminal side of the angle to the x-axis. So that's this angle in here. Since a full revolution is 2 pi radians, you can think of it as I'm stopping pi over 3 short of a full revolution. So my reference angle is actually pi over 3, which I do have on my table I memorized. So let's see, pi over 3 cosine, that is 1/2. So this is 1/2, and now I just have to make sure is it positive or negative. In this case, it's actually still positive because all my x's are positive in the first and fourth quadrant, and the definition of cosine is x over r, so we're good to go. This is our solution. It's our exact value. So sine of 15 pi over 4, we're going to find the exact value of this. So first off, you can take any angle and subtract or add 2 pi to it, and whatever that trig function is at that angle will still be the same value. So I can subtract 2 pi as many times as I need to, because ideally I want to get this between 0 and 2 pi. I guess you could technically still graph it like this, but I like to subtract 2 pi until I get something that's between 0 and 2 pi. It's just easier to deal with. So if I subtract 2 pi, that's like subtracting 8 pi over 4, right? Finding a common denominator. So really what I'm finding is the sine of 7 pi over 4. So I've subtracted 2 pi, now it's between 0 and 2 pi. Now I can draw it and find my reference angle and find the value of it. So 7 pi over 4, I'm going around to about here. That's 7 pi over 4. I can tell that's 7 pi over 4 because, again, I have 4 pi over 4 here, 6 pi over 4. The best way, if you're really confused about which quadrant is in, is just draw all your all these values, like the quadrant values, like pi, 3 pi over 2, pi over 2, all that stuff with the common denominator of whatever you have, whatever you're looking for. So if I did that, I would write this as 4 pi over 4, 6 pi over 4, 8 pi over 4. I could see that it's actually directly halfway in between these two axes. So this is 7 pi over 4. My reference angle is this angle here if I'm drawing up to the x-axis. So again, you think of it as a full revolution is 2 pi, which is 8 pi over 4, and I'm stopping basically pi over 4 radians short of a full revolution. So this angle here is pi over 4. Sine of pi over 4, I have that here on my table, that's root 2 over 2. Since we're in the fourth quadrant, we are going to be negative, so this is going to equal negative root 2 over 2. Okay, here we have cosine of negative 2 pi over 3. And again, this is another reason why I do not agree with memorizing the unit circle, is because then students see this and they don't really know what to do because it's negative. It's not a value that's on the unit circle. So what we can do, again, I can add 2 pi to this, or I could just draw the angle. That's actually what I'm going to do in this case, is just draw it. But either way would work. If you added 2 pi to it and either looked at your unit circle or found a reference angle of that, that would work as well. But I know since it's a negative angle, I'm just going to come clockwise instead of counterclockwise. So it's going to be something like this. Negative 2 pi over 3, that's something around here. And so my reference angle, I'm still going to draw, even though I'm negative, I'm coming clockwise, I'm still going to draw the angle from the terminal side to the x-axis. So it's still going to be this angle, which is what? Pi over 3. So what's the cosine of pi over 3? That is 1/2. Am I positive or negative? Well, I'm in the third quadrant. All my x's are negative, so I am negative. So this will equal negative 1/2. Negative 1/2. Okay, now I have tangent 7 pi over 6. It's getting a little bit tricky because this is not on my table, but knowing some basic identities helps, and that's how I'm going to actually find this. But first I need to find the reference angle. Okay, so again, 7 pi over 6. We're going just a little bit past pi, and actually we're going pi over 6 radians past pi. That's going to be my reference angle. So what is the tangent of pi over 6? We're having to do a little more work now because it's tangent. Tangent of pi over 6, well, that is sine over cosine, right? That's an identity for tangent. Tangent theta equals sine theta over cosine theta. So that's one way we can think of it. So I can write sine of pi over 6 over cosine of pi over 6. I'm going to go ahead and do that. Sine of pi over 6, 1/2 over root 3 over 2. Okay, since I'm dividing two fractions, I can flip the bottom and multiply. My 2's are going to cancel pretty nicely here, 2 and 2. And I'm left with 1 over root 3, which we usually rationalize the denominator. So 1 over root 3. If I multiply by root 3 over root 3, I'll be left with root 3 over 3. And wait, I need to check, is it positive or negative? It actually is positive because tangent is positive in the third quadrant because x is negative and y is negative. And since tangent, the definition for tangent is y over x, they're both negative, so tangent will come out to be positive in the third quadrant. So this actually is our final exact value. All right, now we're looking at secant. Secant of pi over 2. This angle is what we call a quadrantal angle. So these are actually some of the easiest angles to find because I can just draw my little cross here. I don't even have to draw an angle. If it's any quadrantal angle, all you have to do is draw a point wherever that is. So since pi over 2 is right here, I'm going to draw a point right there. And then I could think of, well, what is my r, what is my x, what is my y? It's clear to see that my x is 0 because I'm on the y-axis. So x is 0. Y is 1 and R is 1. If I think about it in terms of like a unit circle, I have Y is 1, R is 1. Okay, because remember, R is that radius of that circle. So this distance is 1, which means the Y value must also be 1. Okay, so I have X is 0, Y is 1, R is 1. So now I can just use the definition of secant, which is what? R over X. So R over X equals 1 over 0. So this is undefined. Undefined. Alright, so by memorizing these values, we can find sine and cosine clearly because we have those memorized. And the trick I use is 1, 2, 3, 3, 2, 1. That's a little mnemonic I use to memorize these values. These are basically the first quadrant values. And I can find any of the other trig functions, like we just found tangent, using just basic identities. I know that cosecant is the reciprocal of sine, secant's the reciprocal of cosine, cotangent is cosine over sine, right? Using these identities, I can use these values for sine and cosine to find these without having to memorize a bunch of extra stuff. So I'm going to show exactly how to do that now. All right, cosecant of negative pi over 6. I could add 2 pi to this, but I know how to draw this, so it's not too much of an issue. I'm just moving clockwise. So my reference angle is actually clear. It's pi over 6. So what is cosecant of pi over 6? Cosecant of pi over 6. Well, that's just equal to 1 over the sine of pi over 6. which equals what? Well, the sine of pi over 6 is 1/2, so 1 over 1/2. 1 over 1/2, and that's actually equal to 2. Now, you can't forget this step. I have to make sure, since I found a reference angle, I didn't actually evaluate cosecant of negative pi over 6. I evaluated cosecant of pi over 6, which is going to be the same value, except it may be positive or negative. I need to look at the quadrant. We're in 1, 2, 3, quadrant 4, and since cosecant is r over y, I have my y as negative, r is always positive, so this will be negative. And the quadrants where sine is positive, cosecant will also be positive. Where sine is negative, cosecant will also be negative. The reciprocal always follows the same sign for those quadrants, so that's something to note. Okay, secant 5 pi over 3. Let's go ahead and draw this. 5 pi over 3, so I'm rotating all the way around. I'm in the 4th quadrant. As you get more experience with this, you'll be able to just look at it and tell exactly where you are and what your reference angle is. So your reference angle for this is pi over 3. So I have secant pi over 3, which equals 1 over cosine of pi over 3. Okay, cosine pi over 3 I do have on my table, that's 1/2, so 1 over 1/2, I'm getting 2 again. Is it positive or negative? Let's see, I am in the 4th quadrant, my x's are positive, so this actually will be positive in this case, so I have positive 2. Alright, for this last angle, I can go ahead and I can see that this is bigger than 2 pi. 2 pi would be 6 pi over 3. So I can go ahead and subtract 2 pi right off the bat because this will be equivalent. This will be equivalent. So subtracting 2 pi, I have 2 pi over 3. Cotangent 2 pi over 3. So now I can draw this. 2 pi over 3, I'm right about here. My reference angle is pi over 3. So I can go and evaluate cotangent pi over 3, then I just have to check my sign to see if it's going to be positive or negative. Cotangent pi over 3. And again, cotangent is the reciprocal of tangent. Tangent is sine over cosine, so cotangent is cosine over sine. So I have cosine of pi over 3 over sine of pi over 3. Let's look at my table. Pi over 3, that's 1/2 over root 3 over 2. And again, I can flip and multiply. Flip and multiply. So I have, I'm sorry, the 2 is on top. I gotta flip. I have root 3 on the bottom, 2 on top. You could think of this also as multiplying top and bottom by 2 over root 3. That works as well. So again, my 2's cancel nicely. I have 1 over root 3. I'm going to move down here. I have 1 over root 3. And once I rationalize the denominator, 1 over root 3 comes out to be root 3 over 3. So is it positive or is it negative? Let's see, I'm in the 2nd quadrant. So my x's are negative, my y's are positive. And since cotangent is x over y, I will actually be negative. This will be negative. Alright, there's a bunch of examples of finding exact values of different trig functions. Hopefully this helps. You don't have to memorize too much. I just memorize a few things. You do have to remember some basic identities. You have to know how reference angles work, coterminal angles, all that stuff. So hopefully this video helps. Make sure to hit like, hit subscribe, leave any comments below, and keep flexing those brain muscles. See you in the next video.